Today we're going to focus on chapter 9, which is financial mathematics. We did a lot of financial mathematics in earlier grades, but our focus for today is to make sure that we cover all those ideas that are incorporated in grade 11. So what you did in grade 10 will progress, and the progression includes all the additional ideas like timelines that we need to understand. So in this chapter, the additional thing, as I said, that you need to know, it would be what happens if you add or withdraw a certain amount of money along the investment horizon. Right? So that is going to have to be dealt with using different techniques. So that's basically what we're actually going to learn here. But we'll start off with revision, which is basic stuff that you did in grade 10, like your simple interest, your compound interest, what is the difference between the two. But now the focus is just going to be on annual compounding. We'll then also just move on and discuss the frequency of compounding whenever we're dealing with compound interest. Right. So, simple interest is interest calculated only on the initial amount invested, which is your principal amount, right? So if this is simple interest, our formula for simple interest is A, which is equal to P in bracket 1 plus I multiplied by N, right? And obviously, you invest an amount P, which is your principal amount. Remember guys, the principal amount is the amount either borrowed or invested. And you always borrow money today, which means that P is always happening today at time 0, right? And the accumulated value happens at times N. So A is then accumulated value, because a principal amount accumulates to a future value that is a lot bigger than the principal amount. And the reason why that is the case is because you need to, because of time value of money, there is some sort of interest that you will be earning on the initial amount invested, or you will have to pay interest on an initial amount borrowed, right? So the initial amount is happening at time 0, which is our principal amount, P, and accumulated value, which is the future value at some future date, is happening at time N, right? And with this formula, A is obviously your accumulated value, P is the principal amount, that's the amount borrowed or invested, and then you've got your I. So you'll be given an interest rate percentage, you need to divide it by 100 to convert this into a decimal. If you look at this formula, all these numbers are real numbers, right? So you need to convert from percentages to real numbers so that you're working with the same type of numbers, which are real numbers whenever you calculate your accumulated value, right? And then N is the time, right? The time horizon. The time until we get to the accumulated value. So if you look at the definition, simple interest is calculated only on the initial amount invested, which is just the principal amount. So it's calculated on the principal amount and nothing else, right? That is the fundamental difference between simple interest and compound interest, which is what we are about to discuss right now. So with regards to compound interest, interest is earned on the accumulated amount and on its accumulated interest, right? So in a nutshell, what we're saying is that interest is earned on interest, right? If you've got an investment that has a time horizon of 5 years, right? If you were using simple interest, you'll just charge interest once on the initial amount. But if I was dealing with let's deal with our compound interest, yeah. Right, obviously, accumulated value, the formula for compound interest is A in bracket P. A equals to P in bracket 1 plus I raised to the power of N. Again, P is the principal amount, I is the interest rate, and then N is the time horizon. If I were to draw like a timeline for compound interest, that's P, that's A. So, by the virtue of its definition, we are told that whenever we're dealing with compound interest, you have to earn interest on interest. And it kind of makes sense, because if you look at our simple interest, right, your interest does grow, but because you charged you charge your interest on a single amount, your interest grows in a linear form, right, where this is your accumulated value and then this is your time. as time advances, your interest grows, but it grows in a straight line fashion, right? And you can see that even the compound, even the simple interest formula resembles that of a linear function on a straight line. So, as much as you still have growth, and that's a straight line with a positive gradient. As much as we still have growth, but our growth is on a linear basis. But if you look at compound interest, interest is end on top of interest, right? So which means that the accumulated value accumulates to time 1, right? And it becomes an amount that is bigger than the accumulated value. And then you add interest again on a bigger amount, right? And add interest again on a much more bigger amount. Because as you go from year to year, your amount keeps increasing. And when you calculate your interest, you keep accumulating it and calculating it on values that are a lot bigger than the preceding values. That is why with compound interest, the accumulated value is always going to be bigger than when you are dealing with simple interest, right? And if you look at the formula here, this is exponential with value functions, right? And this is exponential in nature, right? So, which means that the growth path for accumulated value using compound interest is going to be a lot sharper than it would have been with a straight line. And as we agreed, there's still growth, but the growth is not as rapid as when you are dealing with compound interest. So since this is an exponential amount, exponential function, as your accumulated value grows in an exponential way. So it grows faster in a very short space of time because you are adding interest on top of interest. And then the accumulated amount is always the final amount. It's basically the sum of the principal amount and the interest paid, right? For any interest type, whether we're dealing with simple interest or compound interest, the accumulated amount is always going to be the principal amount plus the interest. Remember, you need to pay for borrowing money if we are borrowing money in this instance, or if you invest money, you've got to be paid some sort of interest to cater for the opportunity cost. Remember, this money that you are investing, right? You could have used it for something else. Opened up a spaza shop, and when you open up a spaza shop, you can actually make profits that are a lot more bigger, right? So there is that opportunity cost. That's why you always have to charge interest when you invest or when you save money, and you will always be charged interest when you borrow money because of that opportunity cost. We could have used that money to add more income somewhere else. So something has got to compensate. Just as much as everything has a price. When you go to the shop to buy bread, you exchange, right? In return of you have to pay some sort of an amount of money in order for you to get the bread in return. But with regards to money as well, when you go to the bank, you've got to pay for the money, and you pay that through the interest. So always know that the accumulated value will always be the principal amount plus the interest paid, right? Right. Now let's look at the following example, right? That's example 1. So we are told that Karabo wants to invest 3,450. Right, remember what we said, P. So what is very important, guys, in financial mathematics is for you to have the ability to pick out key information in the question that is given to you, right? So it's very, very important that you always know how to identify key components that you need in order to calculate the accumulated value or whatever that you would need to calculate, right? So in this case, remember we said that the amount borrowed or invested is always going to be your principal amount. And we are told that this is basically being saved up for 5 years. So we already know that we have our value for that. So FNB offers a savings account which pays what? You've got to be very attentive when you read the question. So they told us that simple interest, and the value of the simple interest is 12.5. And we've got another bank which offers a savings account paying compound interest at a rate of 10.4% per annum. So now the question requires that we are required to answer is which bank account would give Karabo the greatest accumulated balance? Remember, the accumulated value is A. We need to know which bank account is going to give Karabo the biggest amount of money over the same time horizon. Everything is the same, but the difference is the interest. One bank is offering simple interest of 12.5% per annum, and the other bank is offering compound interest of 10.4% per annum. You can see the interest rates are quite different. And remember, what's the difference between the two? The accumulated value for simple interest is always going to be less than the accumulated value for compound interest. But even in the case where we are given different interest rates, In the case where we are given interest rates, we know that with compound interest, we are going to earn interest on top of interest. Right, so now let's actually start with the simple interest question. So with the simple interest, this is what is given to us. We are given the accumulated value. So we need to find the accumulated value, right? But what is given to us? The principal amount, and that's 3,450. It's given there. And we know that n is going to be 5 years. And the simple interest that's given to us is 12.5. So you're going to take 12.5 and you divide it by 100, and that gives us 0.125, right? So basically, if I were to draw a timeline, I'm saying at time 0, I'm investing 3,450 at time 0, and I need to know what this amount is going to accumulate to in 5 years' time. So that's the A that we're trying to basically calculate in this regard, right? So now let us go. We know the simple interest formula is A in bracket P, 1 plus I multiplied by N. And then we just actually substitute all these key values. I've got 3,450, which is multiplied by 1 plus what's the interest rate, 0.125, and what's N? N is 5. So what you then need to do is to then put this in your calculator and calculate the final value. So let us do that. So we've got 3,450 in bracket 1 plus 0.125, and that should be multiplied by 5, close brackets. So we should also just close this bracket. And that gives us an amount of 5,606.25. So that is what Karabo is going to basically have as a balance in 5 years' time if she invests her money with FNB. But now we go to HBC, obviously, that's FNB here, and then we go to HBC Bank, and HBC Bank offers compound interest, right? So with regards to the compound interest, remember everything stays the same, right? Everything stays the same. That's HBC Bank. So the principal amount still stays 3,450, and then obviously the N is 5 years. But the interest rate now changes because for compound interest, we are told that we've got 10.4. Remember, you always have to divide that by 100, which is then 0.104. And what we're looking for is the accumulated value in 5 years' time. So even when we draw a timeline here, we've got at time 0, we've got 3,450 invested. So we need to know in 5 years' time how much will the value be. And that's compound interest. So we know that our formula for compound interest is the principal amount plus the interest raised to the power of the time horizon, which is N. And then we've got 3,450 in bracket 1 plus the interest rate is 0.104 raised to the power of 5, because the time horizon of the investment is 5. So let's calculate this. We've got 3,450 in bracket 1 plus 0.104, all of that raised to the power of 5. And that gives me an amount of 5,658.02. So let's look at these two amounts, right? So everything was the same. We saved up the same amount of money for the same time horizon, but the interests were different. One was quoted on a simple interest of 12.5%, and the other was quoted on a simple interest of 10.4%. And look at the power of compounding, guys. With compound interest, the interest rate was a lot less than what it was for simple interest. But however, we still managed to get a bigger amount for compound interest than we did with simple interest. So it shows that compound interest is powerful. So which is what is used in banks right now. If you were to go to the bank and borrow some money, the bank would then quote you on compound interest. Even when you save money to the bank, you get to pay compound interest. Because we know that with compound interest, you earn interest on interest. And the accumulated value is a lot bigger because every time period you compound, meaning that you keep earning interest on amounts that are bigger and bigger and bigger. Hence, this is exponential. So therefore, it means that Karabo will have to choose HBC Bank, because HBC Bank would then guarantee an accumulated value that is a lot bigger than what ABSA, than FNB would have offered.